Next up is the Dean Emeritus of the Sloan School, Glen Urban, who we were very, very happy to get him back to doing what he does best, which is great research. And he'll be talking about deep learning. Glen.
Well, probably one of the most mentioned techniques today was deep learning. And I remember last year we had the CEO from Deepmind here, and I went away saying, I wonder, would that work for marketing analytics? We know a lot about facial recognition, voice recognition, handwriting recognition, where deep learning has made a big dent. But I've always done analytics, modeling, measurement, decision support. So I said, I wonder how that would happen. So what I'd like to do is take 15 minutes to share with you the results of a feasibility project about what deep learning can bring to marketing analytics. We look at a particular area, new product development, and try to see whether big data and deep learning can identify opportunities for better products. And I think Renee may have walked off with my clicker. Here. So we're going to look at the new product development process, but at the front end, opportunity identification, often called the fuzzy front end. Can we use big data from click streams on websites to identify opportunities for new products? Now, as I started this, I was really kind of thrown back by the mystique of deep learning. It looks like it can do everything, and most recently beat the best player in Go, best person in the world. So this is a very powerful technology. But as I dug into this, and of course we have some of the greatest experts here at MIT in deep learning, so it's a great place to learn what's happening, and we have great graduate students. Santiago Perez, a master's student in computer science, has worked with me, and he knows deep learning, and I know marketing, and we really we're able to be synergistic there. So best way to think about deep learning and how it actually works in marketing analytics is think of machine learning as the outer circle, and think of statistical regression, a technique probably all of us know very well, as a subset. So I want to contrast the differences, and I think when we contrast the differences, you'll see the capability that you can employ out of deep learning. First big difference is that on the left there, regression has a bunch of independent variables, and we predict a dependent variable, sales as a function, price, promotion, whatever. So we define the variables, we predict. Deep learning is represented on the right. It's called neural networks. So we have observed values on the bottom, think pixels for an image that we want to identify, facial recognition. In between are what are called latent layers. There's no measured variables there. They're constructed. And it's called deep learning because we construct 2, 3, 4, or more of these layers. Then they predict a dependent variable. So you see the similarity. We're trying to predict some behavior, some image recognition, some sales level based upon independent, but the deep learning is going to have a much more complex model. All those linkages are weights that we estimate, and each layer is non-linearly linked to the next layer. So you can think of it as a super regression technique with new capabilities, and some of the differences you might see here are, how many have taken an econometrics course? Remember maximum likelihood, R-squares, Fs. We're really concerned with the statistical properties. Is this significant? And we have a database, and we usually fit that database, and we look at its significance. Deep learning doesn't do that. Deep learning has almost no statistics, but it has huge databases. So it takes a small part of the database and trains the neural network to behave well. And then it predicts on the saved data. And it's the prediction accuracy that controls whether we say we have a good solution in deep learning. So it's not so much the theory of how that estimate has good econometric properties, but it works. It predicts. So that's a very fundamental thing to keep in mind as you move forward. Secondly, the regressions are usually very simple, and we usually define the variables from theory. So we try to say, what variables should we include? Now, how do we get good measures on it? So when Renee and I are working on the effects of the stimuli, we say, well, we've got the treatment effects, we've got the covariate effects, we select variables, and then we can interpret by the coefficients how they affect the dependent variable. In deep learning, it's quite different. We have a very complex neural net, and it does predict well, but it's almost impossible to tell exactly how each variable at the bottom works its way to the top. There's so many interactions and so many weights. The interpretability is one of the things you lose when you do the deep learning in most cases. As I mentioned on the data, we often have small sets. So in regression, we'll use selected data. Maybe it's experimental, test control, pre-post, changes in consideration. In deep learning, we take lots of data. If it's not good, it won't turn out to be good. But get click streams from 100,000 people, low cost. Don't do that market research that costs so much, $100 per person. Collect all this data, and let's see what we can learn from it. And lastly, you really have a very different vocabulary and jargon and history. So statistics is econometrics, regression. Deep learning is AI, machine language, machine learning. And one of the first things you find when you do this is that they speak different languages, but often the same because there's this isomorphism between the statistical techniques and the learning. Last thing we'd say about deep learning is in comparison to regression, where we maximize likelihood with simple analytic function usually, in deep learning, the error curve, the difference, least squares, the error is very complex surface. And you navigate around by an algorithm, which starts at a point, trains the model, evaluates its prediction, and then says, oh, we didn't get it right. Then it takes the gradients of that complex surface and back propagates the error to change the weights and keeps going. And this may go hundreds of times until you fit the model with the algorithm. And one of the breakthroughs that happened in the last 10 years where this has really come about is computation and efficiency in the algorithms. Many of these things were known back in the 80s, but were not feasible to do. So it's big data, big technology that makes it happen. So how do we take that now and look at new products? So what we're going to try to do is say, let's take a specific case, in this case, credit cards. A reason being the Suruga Bank of Japan was the sponsor, and we wanted to be relevant to the financial world. We create, in this feasibility study, a synthetic database. So we don't actually have click streams, but we're going to create a database of 100,000 click streams. We're also going to create, based on true rules, what credit card they would select. So we will know from that, and we'll compare that to our neural net. So what does our model look like? Well, this neural net starts at the bottom with clicks. So it's clicks on websites related to credit cards, demographics of people and their financial clicking. What's on the top? It's a little more complex than just, is it the correct image or not? We're trying to predict 4 different attributes of the cards. So we're trying to see what kind of card it is, the interest rate, what percent is rebated by rewards, and what the borrowing limits are. And then in between, we have a neural net with 3 hidden layers and 20 nodes on each layer. So pretty complex. And we have about 27 clicks and 100,000 people. So where do we get the data? Here's a typical site, NerdWallet. In this site, if you were looking for credit cards, you would click on various filters. You'd enter your credit score. You'd say something about whether you want fees or not. You might click loans and mortgages, and then they would display some cards, and you would select one of them. So what we're trying to predict is what attributes you would select in a card as a function of your clicks. And that's what the neural net's going to do for us. So here's the view. Generate the synthetic data, generate the true choices, and in this feasibility study, we'll estimate our neural net based on the clicks. We'll predict choices, and we compare the true choices to what we predict. And as I said, we generate the synthetic data based on demographics and how people would click. Then we fill in the gap with the neural net. So what did we find? We generated 100,000 people. We found that we could predict 54% of the attribute vector they would select. That is, we could predict all 4 of the attributes of the credit card that each person would most prefer. And we simulated this with different levels of noise. So it's 54% with 10% noise in the click stream. That is, we know what the true click is, but we modify it 10% of the time to be wrong. If you go to 20% error, you perform less, but we still had about 38% accuracy. It's interesting to look at 0 noise, just the noise itself, and you see 55% accuracy. It can be much higher than that. It depends on the information value in the clicks and the size of the database. So if you went to 150,000 people and you had a more informative database and a more complex neural network model, you actually get that about 80% correct. So in actual practice, it'll depend on how rich the stream is, how much data we have, and how complex our model. If we have this neural net deep learning model, we can actually simulate a new credit card because we know the preferences of each of these people. So this is just a demonstration simulation with 3 existing cards, travel, rewards, and cashback. The optimal additional card to add to this world is a travel card with 3% reward rate, 15% interest rate, a $10,000 borrowing limit, and we estimated we get 15% market share when we also made an adjustment that, of course, all credit cards are not available for everyone. There's a profit model, which is we make money from transactions, we make money from borrowing fees, we pay out rewards, and we have defaults. So for cards that have very high borrowing limits and high benefits and kind of modest interest rates, we don't give those to everybody. You have to have a specific credit score to get that. So part of this optimization is related to the structure of the credit card business. But it kind of demonstrates that if you did have this kind of deep learning model, you could identify some opportunities. You would then take that on and design it, test it in the market, and potentially introduce it. You can do one other interesting thing, and is that once you have the credit card simulated, you can find out who would be most likely to buy it. And this particular card is highly attractive to a bank because the people who would buy this are people who also have good credit scores and are interested in loans and mortgages. So, emerging conclusion, when I kind of said, well, will deep learning be useful for marketing analytics? My current view is quite bullish. I think it can. I think we can use big data, low-cost data, not necessarily eliminating the kind of social experiments we do, but use it in new ways. So we're looking for partners, people who have data, or people who would be interested in joint research in this area. So if you are interested, come up and see me or see us at the cocktail hour. And lastly, we are doing a lot more technical stuff, more machine learning models, Boltzmann models, which are new complex ones. And we're also going to look at deep learning in other marketing areas like brand loyalty, advertising response, or as Renee mentioned, morphing. So if you're interested in any of that, would like to partner, we'd be welcome to talk to you. Thank you.
Questions? You want to take a question or two?
Deep learning can't be that confusing. How many people are using deep learning in your company now? I think this is, as Paul was showing on his chart, this AI curve is going very fast. I think if we come back here 3 years from now, more than half the people in this audience will be using deep learning in their firms.
Thank you.
So yeah, either I made it completely clear or completely opaque. So.
I'm sure you'll have a lot of people talking to you in private.